So hello ma'am, am I audible?
Yes, sir.
So okay ma'am. Chidambaram College, we welcome you all to this 6 days faculty development program on exploring new horizons in mathematical research. Our department was established in 1957 with UG, and it has been elevated as a PG department in 1984 and a research department in 2008. So we are conducting several FDPs and seminars in the years to enhance the knowledge of the professors in the field of mathematics. So today, first of all, I would like to welcome our resource person, Dr.S. Chandrasekaran sir, Assistant Professor of Mathematics, Sri Meenakshi Govt.Arts and Science College for Women, Madurai. Thank you, sir. Thanks for accepting our invitation. And here is your day. And we welcome you on behalf of our department and participants. Welcome you, sir. And I also welcome the various faculty members from various academic institutions, research scholars, and students to this 6 days faculty development program on exploring new horizons in mathematical research. First, I I would like to invite our assistant professor, Dr. J. Martina Jensi, to introduce the resource person to the audience. Please.
Yes, sir. Very good afternoon, everyone. It's my great pleasure to introduce our esteemed resource person, Dr.S. Chandrasekhar, who has joined us today to share his expertise and insights in the field of topology. Dr. S. Chandrasekhar is a highly respected mathematician and educator, currently serving as assistant professor in the Department of Mathematics at Sri Meenakshi Govt.Arts College for Women, Madurai. With a teaching experience spanning over 2 decades, he has been instrumental in shaping the minds of countless students and inspiring the next generation of mathematicians. Dr. Chandrasekhar's research interests lie in the fascinating realms of fuzzy sets, intuitionistic fuzzy sets, neutrophopic sets, and various topological spaces like nanotopological spaces, supratopological spaces, and many more. His work in these areas has been widely recognized and published in numerous international journals and conferences. Today, Dr. Chandrasekhar will share his expertise with us, focusing on recent developments in microtopological spaces. His talk promises to be an enlightening experience, offering valuable insights and practical strategies for us to enhance our teaching and research capabilities. On behalf of PG and Research Department of Mathematics, I extend a warm welcome to Dr. S. Chandrasekhar. Welcome you, sir. We are grateful for your presence and look forward to a stimulating and informating session, sir. Kindly take over the session, sir. Thank you.
Thank you, Dr. Martina Jensi. So now we have handed the session to the resource person. Sir,
Thank you, sir. Thank you. Sir, my voice is audible. Sir, my voice is audible.
Yes, sir.
yes, sir, you are audible.
Good evening, everyone. Student meet. I am Dr. S.Chandrasekhar, Assistant Professor, Department of Mathematics, Sri Meenakshi Govt.Arts, Women, Madurai. V.O.CHIDAMBARAM College University arranged a 6 days faculty program in the title Exploring New Horizons in Mathematical Research. Actually, really appreciate the Department of Mathematics. They have provided a new platform for young researchers. Before starting my presentation, I would like to stress my deepest to principal, principal sir, Dr. C. Veerababu sir, and my special thanks to head of the Department of Mathematics, Dr. Deva Manoharan sir, and faculty members from the Department of Mathematics, and especially Organizing Secretary Dr. S. Jackson and Dr. L. Pandichelli Madam, Dr. J. Martina Jensi, to providing wonderful opportunity to share my research idea in the faculty development program. So now I am going to start my presentation. My topic is recent development in microtopology. My presentation organized into 4 sections. First one, historical background of topology spaces. Second one, concept and then some concept micro topological spaces. Then finally, recent development of micro topological spaces. Dear participants, we can see two images there. One from geometry, another from topology. In geometrically, the shapes are not equal because in geometry measurement is lot of relation. But topologically, the image are T form, one shape, 3A, 3A, another shape. This is the earlier idea of topological spaces. Topology, all features equal, but not equal. Next, the literal meaning of topology is nothing but topology. That means study of surface. A geometrical shape we can sketch, twist, crumple, bend. We can modify one shape to another shape, but not permit tearing or pulling the shape. Early days topology named as a rubber sheet geometry. And that our early time of lot of mathematics not in the topology. Topology is only a shape modification, only geometry. That's why last 100 years mathematicians not interested in the topology spaces. After the 20th century, it grew up a four important fields like a point set topology, algebraic topology, geometrical topology, and differential topology. So, point set topology, based on the maximum result from analysis, it developed a beautiful subject as a topological space. So, everyone says topology is child of geometry and analysis. Topology is child of because these ideas from geometry analysis. That's why topology is child of geometry and analysis. Now we share few background of historical background of topological spaces. Everyone known the famous problem, Königsberg 7 bridges problem. That problem provided a two important mathematical subjects, graph theory and topology. So topology development of origin is the seven bridges Königsberg problem. Okay. Then August Louis Rorty and Hall raised a very famous mathematician real analysis. They are contributed continuity in the limits in real analysis. That idea later applied in topological spaces. Next one, Charge Gander. Everyone known Charge Gander as a father of set theory. So Charge Gander also developed the scientific study of infinite sets and concept of cardinality. This leads to development of topological spaces. Next, Nauri Fresher introduced a very famous mathematics concept is called metric space. Then next one, the Felix Castras. So introduced the Castras space. So this is also very famous concept in topological spaces. And then next one, Alexander Rao. Alexander Rao introduced the concept of complex space in real analysis that in topology also. The Andrew Kolmogorov also introduced the concept Kolmogorov space. Kolmogorov space recently space. In the 20th century, topology we already said four important fields: point set topology, algebraic topology, and differential topology, and geometric topology. Again, Poincare lead to contributed development of algebraic topology. John Milner contributed so many ideas in differential topology. In algebraic topology, the homology, that idea developed from Albrecht and Matic. These are the historical background of topological space. Dear friends, everyone knows this is a fundamental definition of topological spaces. Okay, is everyone known? Simply skip. So next one, I give example for x equal to a comma space, two element space. In x equal to a comma b, the two element space we can form only four topological spaces. Suppose we take x equal to a comma b comma c, three elements. For that time, we can maximum make 29 topological spaces. Suppose we choose x equal to a comma b comma c is four elements. We can form maximum 365 topological spaces. Suppose we choose uh, five elements x equal to a comma b c d e. For the time we can form maximum 6,942 topological spaces. We choose x equal to 6 elements for that case. We can form 20 lakh 95,027 topological spaces. Similarly, for the case of 7, we can form 95 lakh
Sir,
33.
sir, sorry for the interruption.
Yes, sir.
Sir, kindly share your PPT, sir.
Sir, excuse me, sir.
Yes, sir.
Sir, your PowerPoint slide didn't move.
It didn't show us, sir.
Move agla, sir. And also the audio is not clear
Yeah, it's
for the
breaking.
past 2 to 3 minutes.
Sir, now move on.
Sorry for the interruption, sir.
Sorry, please. My mic problem. Sir.
No, sir. Still, the voice is not audible.
Hello, sir.
Sir. Now it's okay.
Okay, sir. Okay. Thank you.
Okay, and the slide is not slide move agla, sir. Slide அந்த ஃபர்ஸ்ட் ஸ்லைட்லயே இருக்கு. அது மட்டும் கொஞ்சம் பாருங்க சார்.
Slide is moving, sir. Sir,
சார்.
slide is
ஸ்லைட் ஷோ இப்ப தெரியல சார். இட்ஸ் நாட் விசிபிள்.
yeah, please wait. Wait. Sorry for 3 minutes.
ஜென்சி மேம், could you present from your end?
Yes, sir. Yes, sir. Sir, shall I share your PPT?
Yeah, sure.
Okay, sir. Wait a minute.
Dear participants, sorry for the inconvenience. Kindly wait for a minute.
Sir, is it visible now?
Yes, ma'am.
Okay,
Audible.
sir.
Yes,
Voice,
yes, ma'am.
voice is audible, sir. My
Yes,
voice
sir.
is
Yes,
audible.
sir.
Okay, thank you, thank you. So,
Please, sir.
uh, as here we have some uh, table. Suppose we choose x equal to a comma b, two element space. For the time we can form maximum four topological spaces. Suppose we choose x equal to a comma b comma c. For the time we can form only 29 topological spaces. Suppose we choose take four element set. For the time we can form 355 topological spaces. So at the time of x equal 5 element case, we can form maximum 6,942 topological spaces. We take six elements for the time, we can form 20 lakh 27 topological spaces. Similar case as 7, 95 lakh 35,241 topological spaces. The last case, 8 element case, we can form 64 crore 27 lakh 79,354 topological spaces. So this is for basic idea of topological spaces. Next one. Next slide, ma'am, please. Madam,
Yes, sir.
Jayant. And next slide, ma'am.
Yes, sir.
Can I move? No, no, no.
Sir, actually, I have moved 4 slides. So after this table of topologies, the next one
Uh,
is rough set, right?
yeah, yeah.
Yes, ma'am. But it's
Uh,
not moved in the screen.
oh, already I have done, sir. So kindly wait a minute.
Yeah, thank you, ma'am.
Okay, sir.
In actually, this slide we can see the rough set. Rough set theory can to uh, imperfect knowledge or vagueness concept into a this kind of concept expressed into a boundary region. Using the boundary region, we can form we can get a we can get a result. So rough set theory helps vagueness or imperfect concept into the boundary region. Using the boundary region, we can express our result. Next slide, ma'am. Yeah, rough set theory that ideas developed by Jet Fowler in the year 1980. So rough set theory totally have three important areas. First one, information systems. Second one, scientific relation. And last one is set approximation. These are the important concepts in rough set. Next one, ma'am. Yeah, this is a information system. A patient have a flow. Uh, this this information system organized as a table manner. Here, next slide, ma'am. Yeah. So this information system, we categorize into three cases. In the table, first column E1, E2, E3, E4, E5, E6 are called objects or entities or members like that. So E1, E2, E3, E4, E5, E6 are called objects. So maximum you are using a objects. Okay, next, headache, muscle pain, temperature are called conditional attributes. Then finally, flu. Actually, this table create for the flu diseases. So this is called the seasonal attributes. So a table we categorize as objects. Second are conditional attributes. Last one seasonal attributes. The next one. Another important concept in rough set theory is link-script relations. Okay, this information system we can collect or arrange or grouping same kind of result as a group. For example, I choose only one headache. In this headache, we have two kind of results. Some of yes or no. So we group yes as a group, no as a another group. Yes as a one group, no as a another group. This is called inquisitive relation. Same way in muscle spine. Here also two kind of result. Here also two kind of means yes or no. So maximum result we have yes. So yes cases are grouping as a uh, group. The only one if E5 is separated, there is no case. So separately we can written as a E5. Similarly, uh, temperature concept. For that time, we have three kind of results there: normal, high, and very high. So classified normal as a one group, then high as a group, very high is a group. So this is idea is insubscriptibility relation. So using that idea, we can form a group. We can form a group. That idea is called insubscriptibility relation. The next one. Right. So another important concept in set theory is approximation. So approximation in totally we have four kind of approximation. First one is called upper approximation, here lower upper approximation, boundary region, outside region. So rough set theory we can classify into the four cases: upper approximation, lower approximation, boundary region, then outside region. So, so here we have a condition for lower approximation. So for that time, we need two cases: one conditional attribute, next one inscriptive relation. So comparing conditional attribute and inscriptive relation, we have to find subsets from the inscriptive relation. That is called lower approximation. Same way. Upper approximation, we denote that upper approximation denoted by P bar of x, lower approximation denoted by P suffix x. So finding method of upper approximation is nothing but compare conditional attribute and inscriptive relation. We make each element. We go to find which case we get result non-empty. That collection is called upper approximation. So next slide, ma'am. So boundary region is the very easiest one. So difference between upper approximation and lower approximation is called a boundary region. So last one case is also there. Outside region. Outside is condition for outside region is U minus upper approximation. What do you mean U? U is a object, collection of objects minus a difference of upper approximation. This is called the outside approximation. Next. Okay, thank you. Here we have one more information system. Here we go to find the value of upper approximation, lower approximation, already here. Here x1, x2, x3, x5 up to x1 are called objects. So here we have two conditional attributes. One is age, another one is called length. Length is nothing but leg-oriented diseases. Okay. So first we form a inscriptive relation for both cases, age and length. So we go to find inscriptive relation for both cases, age and length. Okay. In age side, first choose x1. Age limit is 16 to 30. So age wise, three places also the age limit 16 to 30 available, three places: x1, x2, and then x6. But for this place, length value is not same. So we can write x1 is separately. Then x2 also length value is not same. So x2 write separately. Then another case, age limit is 31 to 45 and length value 1 to 25. So here x3 and x4 have both are same. So we can grouping as a one collection x3 and x4. Similarly, another one age limits are which one 46 to 60. So two places there the place of x6 and x7 age limits are same, length values are same. We can easily grouping. So x7 is a group. The last one x6 here length value different. Even though age value same, but uh, here length value is different. We can write separately. This is our intrinsicity relation. In next, we go to write here conditional attributes. In conditional attributes, we have two kind of results. First results are first one is yes, and then now I am going to yes as a
Sir,
yes.
sir, sorry to disturb, sir. Sir, your voice is breaking, sir.
Hello, ma'am. Hello, hello, hello. And upper approximation and boundary region, outside region. We can form above example, we can form a result. That result formulated as a table. This table, it is easy to understand what is upper value, what is the lower value, what is the boundary region, what is the outside region. So, rough side theory provide uh, provide a very good platform to the sharing a research idea into the table manner. Okay, next slide. Yes, actually, in at the time of publishing a paper in a conference, at the time of sending a paper in a journal, everyone asks what is the application of your research work. Actually, we are topologists, so we are doing research. This is only maximum theorem and proof are only available. But for the time, Dr. M. released introduced a very famous topological concept is called nano topological concept. Using the nano topological space, we can give so many real life applications. So, Dr. M. released developed this nano topology using the above axioms, upper axiom, boundary region, and lower approximation with space U and empty named as a nano topology. So it is a beautiful concept in topology. It is a very beautiful one. Using the nano topology, we can form we can publish so many applications. So even though in nano topology, nano topology is fixed. Nano topology is fixed. So minimum 2 elements, maximum 5 elements. So nano topology have maximum 2 elements, minimum 2 elements, maximum 5 elements. So for that time, we cannot modify insert and addition is not possible in nano topology. It is only fixed. For that time, I introduced the concept is called micro topological spaces. Ma'am, next slide. Right. This is a micro-topological space. Micro-topological space. So micro-topological space is very easiest one. Just using the Levin simple extension concept in nanotopology, we can extend our topological space as our wish. Okay, this is the definition of micro-topological space. First, we need nanotopological space. U, tower of X nanotopological space. For the time, we need one element is called micro element. Here there is one element is there, mu. Mu is a micro element. Okay, so this is the condition mu r of x equal to n union. Okay, n dash intersection mu, where n dash belongs to nanotopological space. Mu is nothing but non-existent element of nanotopological space. Mu is nothing but non-existent elements of nanotopological spaces. Next one. Microtopology satisfies all the three conditions of topological spaces. That's why we can written as a microtopology in the form of U, tower of x, mu r of x is called a microtopological spaces. Microtopological space satisfies all the conditions of topological spaces. And the elements of microtopological space is called micro open sets, and its complement is called micro closed sets. Next one, ma'am. So I am giving on how to create a microtopology from nanotopology. I am giving an example. See, U equal to A comma P, P comma C is a space. Then U over R is a intrinsic relation. X equal to B comma C is a conditional attribute. Using that case, we can form nanotopology. Tau R of X equal to U comma MT comma P comma C. Then mu equal to A. So I choose micro element that is called mu equal to A. Mu does not member of nanotopology, right? So microtopology condition is what? Mu R of X equal to N union N dash intersection mu, where N dash belongs to tower of X, mu does not belongs to nanotopology, right? So N dash is nothing but both elements from nanotopology. First I choose one element U, remaining elements are called N dash. First choose one element U, remaining elements are called N dash. So here U, I choose N as a first element U, remaining N dash, empty set and B comma C are N dash. Using the operation, we get result U. Second case, now I choose pi empty set as a N, remaining U comma P comma C called as a N dash. Make a operation, we get a result empty and singleton A. So another one case, choose N equal to P comma C is a N, remaining elements are called N dash. U comma empty is called a U comma empty or N dash element. Here we are making an operation, we get result P comma C and U. So make a collection, repeated element, write one time. This is called a micro topological spaces. This collection is called a micro topological spaces. Next. Already said nanotopology fixed, minimum 2 element possible, maximum 5 element possible. But using a nanotopology, we can develop it as our wish. Okay. First I am showing 3 element micro element topological space. First form nanotopology, tower of X equal to U comma MT. This topology there only 2 element. For that I choose mu equal to A. For that time we can form micro topology as a mu MT A. So forming a micro topology very easiest one. I give simple way. First take nanotopology, choose micro element, union with each element of nanotopology. Same way, intersection with each element of microtopology. Sorry, nanotopology. First make micro element union with nanotopology. Second, micro element intersection with nanotopology. So this is a very easiest way of forming a micro topology. Very easiest one. Okay. So next one example for 4-element micro topological spaces. So we are introducing one set for the time this kind of is only possible. We can for the time you can use a modified four-element micro topological spaces. So choose my non-member in nanotopology, non-external element U equal to A. For the time we can form 4-element micro topological spaces. Next slide, ma'am. Similarly, choose a nanotopology. Suppose we need 5 elements means now for the time we can use a condition, we can form a 5-element micro topological spaces. So, forming a micro topology is very easiest one. Union one time, intersection, we make a collection. For the time we can get micro topological spaces. The next one is 6-element micro topological spaces. Okay. Next one. Yes. So similarly, 7-element micro topological spaces and then 8-element micro topological spaces. So we can extend, enlarge nano topology as our use. So that's why we named as a micro topological spaces. Actually, anyone researcher start in research in micro topology, you can finish your research work within a 5 months. 5 months also very maximum one. Next, sir. Okay. So in a micro topology, till now only 15 papers are published. Especially most of Iranian professors and Iraqi professors most contributed in the micro topological spaces. Especially H. Ibrahim contributed so many results in micro topological spaces, and then Jagari. Also, Jagari is another one Iranian professor, also contributed in a micro topological spaces. Next one, Bhavani also introduced, Professor Bhavani also introduced some concept in micro topological spaces. Next one, sir. Next one. Yeah, similarly, yeah, like this, only 15 papers published in direct micro topological space. Here, only here also so many results are available in micro topological spaces. Even though now, quite recently, micro topology, ideal topology. So combination of micro and ideal topological spaces formed published on 4 papers. Actually, micro ideal topological spaces form a new platform. You can start your research in micro ideal topological spaces. You can finish your research within a very short time. Only 4 papers are published in the micro ideal topological spaces. Next, same idea with the drill. Actually, ideal or drill more or less same. Even though you start your research micro drill, only 2 papers are published from micro drill topological spaces. Suppose you start your research in micro drill, you can finish your research very soon time. Next, this is a beautiful paper in micro ideal topological spaces. That paper published by Dr. G.C. Janagi Madam. Next, sir. Yeah, this is called a cross-touch topological spaces. Actually, this is similar from micro topological spaces. Based on the micro topological concept, little bit modification, they are introduced to the cross-touch topological spaces. Cross-touch topological spaces, the author then Sajid. First 15 letters of his name. After K-A-S. Then another author, Sajid, S-A-J, S-A-J. The combination of from 3 letters of his name published the cross-touch topological spaces. This is a new topological spaces, similar as a micro topological spaces. Next one. Actually, last 5 years, nutrosonic nutrosonic topological spaces provide a lot of research work for young researchers. Now, combination of nutrosonic and micro topological concepts. Okay, this is a new platform also uh, created now. So start your research, the combination of nutrosonic and micro topological spaces. For the time, you can publish your research article in the from nutrosonic and micro topological space. Nutrosonic topological space is not Permian and electronic research. For the time, we deal with numbers with a what nucleophilic numbers. Okay, for the so you can start your research nucleophilic uh, micro topological space. We have a new platform for you. You can start your research. You can complete your research very short time. Next one, sir. Yeah, 3 application papers are published from micro topological spaces. 3 papers are available. This is another one of the application-oriented papers from micro topological spaces. You can refer. You can also see from so many applications of micro topological spaces. Next, uh, this is a new same idea of nucleophilic and micro topological combinations that is called a nucleophilic micro topological spaces. So this is another one publication came from in the combination of nucleophilic and uh, then next one. Yeah, it's a triple combination. Nucleosophic topologic one space, one ideology. Microtopologic space, another ideology. Ideal topological space is another ideology. The combination of 3 cases, nucleosophic, micro, ideal, for the time, uh, you can form a triplet combination of topological spaces. For this case, only one paper published. You can start with research work, the combination of nucleosophic, micro, ideal, topological spaces. So, microtopology now developed a combination of ideal with microtopology, trivial with microtopology, and then nucleosophic micro topology. Quite recently, and ideal with combination. So you can start with anyone can start with this and finish the research within a. Okay, sir. Question from audience. Any questions, sir?
Dear participants, if you have any queries, kindly unmute and ask. Those who are in YouTube Live can post your queries in the chat box.
Yes, participants, now the platform is open for question answers. Sir, one question from YouTube platform that if all the theorems applied in nanotopological spaces can be proved in micro topological spaces.
Yeah, we can. Uh, every non-topology is a micro-topology. So all the results applicable in micro-topology.
One more question, sir.
Yes, sir. Please
Uh,
ask.
is the micro topological spaces can be used in expert systems?
So micro-topology is nothing but just extension, actually extension concept. Actually, one level to another level. So if you need your field extension for the time, similar you can develop your field. So micro is nothing but extension of simple extension of nanotopology. So we need your, if you want extension your field, just modify as your as your needed result for your wanted.
Okay, sir. One more question from YouTube platform, sir. Up to how many number of elements the micro topological spaces can be found?
Uh, Up to 9, sir. Up to 9. I'm showing only 8. Maximum we can come 9 only.
Okay, 9. Sir, one more question that like neutrosopic and microtopological spaces can combine. Is the soft and other topological spaces can be combined with microtopological spaces?
Yeah, sure. It is possible. Even it is possible. It is possible. Start your research.
Sir, one person has asked, like nanographs, can be formed micrographs?
Graph theory or graph?
Yes, sir. They have asked that in graphs, using nanotopological spaces, we can form nanographs.
Yes, sir.
Likewise, using microtopological spaces, can we produce micrographs?
Yes, sir. Actually, you can start. It is possible. It is surely possible.
Okay, any other questions? Okay, sir. So, I would like to invite our assistant professor, Dr. J. Martina Agency, to propose the vote of thanks. Please, ma'am.
Good afternoon, everyone. First and foremost, I thank the Lord Almighty for His abundant blessings. I express my sincere thanks to our Honorary Secretary, Dr. APCV Chokalingam, our beloved Principal, Dr. C. Veerabahu, for their constant support and encouragement. I would like to express my heartfelt gratitude to our distinguished speaker, Dr. S. Chandrasekhar, for the enlightening talk on microtopological spaces that we have just had the privilege of attending. Your expertise and passion for the subject shone through in every aspect of your presentation, sir. And I hope it is very helpful for the young researchers. You have shown the different directions of possible researches under different topological spaces. And we appreciate the time and effort you took to prepare and deliver this talk and sharing your knowledge and insights with us. Once again, I thank you for the fascinating and informative talk, sir.
Thank you,
And
ma'am.
yes, I thank all the participants from various institutions for your active participations and your queries. And thank you so much, one and all present here. I have posted the feedback link in the chat box. Kindly fill the feedback link for day one. Thank you all.
Thank you, Professor.
Thank you.
And once again, I would like to place my sincere thanks to Dr. Chandrasekhar sir for accepting our invitation and came with a marvelous presentation. Uh, it's a nice inauguration day. The first day is the best day. And thank you, sir. Thanks for your most wonderful and intelligent words.
Thank you.
And also, I thank all my colleagues and participants. In the days to come, we are also going to witness some more worthful talks. So we'll meet you on tomorrow. Thank you. Thank you, dear sir, and thank you, dear participants.